Welcome. My name is Dana Brown. I work for Xojo, and in this lesson, we're going to continue progressing in our Programming with Xojo course. In the previous lesson, we learned about what a data type is. We worked with the string data type. That's the one that we use for working with text data. And we also use the message box function, allowing us to display any text message in a dialog box. When we create an app for the real world, we do need to use other data types in order to manipulate different kinds of data. In order to do that, we need the kind of information that is available from something that's able to store it and that we can refer to later to retrieve these values. Let's think about this like in the way drawers or boxes are able to temporarily store a kind of data, so we can work and operate on them. So if, for example, in the real world, we're used to using different and physical drawers to store a particular kind of object in them, like socks, napkins, cutlery, tools, and such. When it's about coding with Xojo, it's the same kind of thing. That is, we need to define several boxes so we can put only a specific kind of object or data in every one of these. How can we do this? Well, we can do this through the declaration and use of variables. And we can deduce by its name that a variable is in fact the declaration or creation of that kind of temporary drawer. We can identify by labels, so we can know from our code what type of data is stored in a particular drawer, and also set the kind of information it is going to store. To see this in detail, we are going to add a new event. In this case, it is the open event that we are adding to the default window object available in every new Xojo project, so we can access to the associated code editor for the event. This is something that we learned in the previous lesson. So how can we declare a variable in Xojo? In order to declare a variable, we need to use the var keyword, very easy to remember, because it's kind of an abbreviation for the variable word. Next, we need to tell what the label is that we want to associate to this particular drawer. So we can use a descriptive name for that. We don't want to start with a number. We can use any character combination. For example, we can name this label name as a clear hint about the kind of information we are going to store in that particular drawer. That is, we are going to store names on it. As you can see, the code editor automatically includes the as keyword. This is because Xojo and also many other modern programming languages use what is known as strong typed variables. Well, what does this mean? In short, this means that once you declare a variable to store a particular kind of data, it's not possible to assign or store other kinds of data to it. So, if you declare a variable to store strings, you won't be allowed to store numbers on it as well. That is, if you declare a box to store napkins on it, you won't be able to also store socks on it later. So for that, we need to set the kind of data associated with the variable during its declaration. And when it's about code, that kind of information equals to the data type. As by now, the only data type we know is string. Let's set our name variable to store strings data. Once completed this sentence, we will have declared our very first variable in Xojo. That is a variable by using the var keyword, identified by the name label, and that we will be able to use to exclusively store strings data on it. If we would try to store any other kind of data on this variable, then we would get an error every time that we tried to run our application. This is the variable declaration, but at this point, the variable itself contains the default value for strings, an empty string. So if we want to assign a new value to it, we need to do what is called a variable definition. The way to assign a new value to a variable is really simple. For that, we use the name we set to the variable, then the equal operator, and next, the new value we want to assign to the variable. So with this line of code, we will be assigning to our variable, identified by its name label, the hello value, matching the string type. In fact, we can simplify these two lines of code in just a single step. That is, we can simplify the declaration and definition of a variable in a single step. That would be var name as string, and next the value we want to assign to it. In order to test our first variable, let's use the message box function we already know from the previous lesson. Remember from the previous lesson that message box expects a string as its argument, and in that case we were using a string literal. Now we can simply use our variable instead of typing a string literal as the text to be displayed by the message box dialog. So simply type the label of our variable name. If we run our app, we will see how we get the same result, except that we are now using the string stored in our name variable, instead of using a string literal for the message box dialog. And as I previously said, we can always change the variable's content. So if we initially stored the text hello into our name variable, next we can store any other value. In this case, if we run our app, we can see the new value we stored in the last place into our name variable. And of course, we still can do the same kind of operations we were used to doing as we already saw in the previous lesson. That is, we can also use the following syntax. We can assign to our name variable the current content stored in it, and then add a new value of string type to it if we run our code. We can see how the message box displays the addition or concatenation of both strings, which is the initial value stored in our variable and the result of adding a new string into it. So these are finally assigned again to the name variable. But of course, when it's right about writing your own apps, you will need to also use other data types, apart from string. In fact, probably one of the data types you'll be using more often would be the numeric ones. And for that, we can find several data types in Xojo. In order to store large integer data types, that is, without a decimal part, to work with numeric values where you need to preserve its decimal part, and also to work with values with a decimal part, but where you need to preserve the maximum precision. This could be, for example, the case where we need to do mathematical operations where even a minimal loss would result in something not desirable. This could be the case of working with numerical values representing currency figures. How can we use the numerical values in Xojo? Well, we can declare our numeric variables in the same way we do when declaring string variables. For example, to declare a variable of integer data type, we use the var keyword, the label we want to use to associate to our variable, and next the integer data type. That is the data type in order to use values without a decimal part, for example, 25. When we need to refer to values with a decimal part, we can opt between a single, that would be the one with simple precision, or double, offering more precision, being the one we probably will want to use more often. In this case, the assignment of the value to the variable would be typing a dot to set the decimal part of the number. So we can see here the representation of an integer value and the representation of a real number. And if we need to work with currency values, in order to work with the maximum precision, we can use the currency data type. As it happens with the string data type, when we work with numeric values, we can do all kinds of operations on these. One would be addition. Another is subtraction. A third one is multiplication. Then division, and also a division variation where we don't need to preserve the decimal part. That is, we would get the division result as an integer value. We can also work with exponential operators, so we can multiply the base number, the amount of times represented by the exponentiation value, and also use the module operator, so it gives us the rest gotten by the division of the two given values. Let's change our variable names and also their data types. So all of them are double type. So the way to do addition using numeric values would be, in this case, the result variable would store the addition of value stored in the first variable with the value stored in the second variable. In this case, the result variable will store the subtraction between the values stored in the first variable and the one stored in the second variable. So the result variable would store the value found by multiplying the value stored in the first variable with the one stored in the second variable. In this case, the result variable would store the right value found by dividing the value stored in the first variable with the one stored in the second variable. The difference then is that the result variable would store just the integer part of the number found by dividing the numbers stored in the first and second variables. So remember that the inverse slash operator gives as its result just the integer portion of division, discarding the decimal part of the division between the given numbers. So here the result variable will store the result found by the exponentiation of the value stored in the first variable raised to the value stored in the second variable. And in this case, the result variable will store the rest found by dividing the value stored in the first variable with the value stored in the second variable. In order to see the result of these operations, let's use the well-known function message box, passing along, for example, the literal string addition as part of its argument, and then typing the name of our result variable. Let's try to run the app and see what happens. As you can see, when we try to run the app from the Xojo IDE, it throws an error to us in the line of code marked by a bug icon. And in the lower area of the window, we can see with more detail what the error is. Xojo is telling us that it's a type mismatch error and it was expecting a string data type, but it received a double data type instead. So in effect, result variable is declared as a double, and if you remember, message box expects an argument of string data type. This is related with what I previously said about how we can't add, for example, pears and apples, and also what we saw about strong typed variables. That is, a function or a variable expects to work or store a given data type. We can't give or store to them a different one. So how do we solve this problem? What can we do to convert our numeric value into a string type value? Well, the Xojo framework offers several options to do just this kind of conversion from a numeric value to a string value. So we can use it when a function expects a string as an argument. If you remember in the previous lesson, we saw that any object has associated with it a number of events, methods, properties, etc. So we can access these using the dot notation. And in this case, it is kind of the same as what we declare a result variable so it can store double values. So we'll simply use the dot notation and press the Tab key, we would be able to access all the method names or functions that we can use, and one of these is, in effect, toString. If we select this one and we watch at the lower area of the code editor window, we can see that toString method gives us the string representation of the value given as a double data type. So we're doing just that. We are giving to the toString method the double value stored in our result variable, and then the method gives us back the same value represented as a string data type that we can add to another string for message box. We repeat this same line of code for each mathematical operation in our example. Here would be the subtraction. Here the multiplication. Here the division. And here a division with an integer result. Here's the mathematical exponentiation. And finally, the module mathematical operation. That is the result found by dividing two numbers. Next, we need to assign the initial values. For example, we can give the 13 value to our first variable and the 4 value to our second variable. We can also express these as numeric values with the decimal part. We run our example app, and we can see how the result of the addition operation is 13 plus 4. And in effect, that is right, 17. Here we can see the result from subtracting 9. We get 52 as the result for the multiplication operation, 3.25 from our division operation, and just 3 from the division operation that discards the fractional part. Here is the result from our exponentiation operation, and here is the one from the module operation, that is the rest found from dividing the numbers stored in both variables. But when we work with these numeric values, we need to take into consideration some additional behaviors that may seem like the expected ones or not. Maybe one of the most significant would be the one we're going to see next. Let's suppose that we only have this variable, and we want it to store the result found from the following mathematical operation. What result would you expect from this expression, and thus stored in our new variable? Probably you may think that it would be the one found by adding 2 plus 2 and then multiplying it by 5. Let's see if we're right. As you can see, the one we got is really far from what we expected. In fact, we get 12 as the result of our mathematical expression when we were probably expecting 20 as the result. That is 2 plus 2, and then the result multiplied by 5. Why isn't this the case? Well, when we do mathematical operations, and this is also something that applies to other programming languages we are faced with, something called operator precedence. That is, the operator precedence determines the operation that is evaluated in the first place. In this case, mathematical operations like multiplication or division takes a higher precedence than that is, they are evaluated before the other addition and subtraction operations. So if we were expecting that it would go from left to right adding 2 plus 2 first and then multiplying that result by 5, the truth is that the first operation evaluated is the one multiplying 5 by 2 and then adding that result to the other component of the expression 2. So that explains that we get 12 as a result, being the result stored in our result variable that we can use later as the argument for the message box function. How can we alter the mathematical evaluation precedence? Really easy, actually, as we're used to doing from our times as students. That is, using the parentheses to set the mathematical operation that we want to be evaluated first to alter the default precedence. For example, we set a higher precedence to the addition, so it will be evaluated first from left to right, and then it will be the result multiplied by 5, probably what we wanted from the beginning. If we run our app again, we can see how the result displayed by the message box is the one we expected. What is the second thing we should be aware of when working with numeric values? Well, let's see it through an example. We declare the integer result variable, whose data type is integer. We also declare the first variable, whose data type is integer, and the second variable, whose data type is double. We assign the value 10 to the first variable and the value 12.60 to the second variable. And next we assign the result variable, the one we got by adding the first and second values. What would we expect in this case? Well, let's see. As you can see, the decimal part has been discarded in the addition result. That's because we are storing the result as the mathematical operation into a variable declared as an integer type. And as we should already know that an integer doesn't store decimal values, the way to solve that is as easy as changing the declaration of the result variable so its data type is double instead of integer. When we execute our app example again, we can see how we got the expected result, and also including the decimal part values of the addition. Here are some of the other topics we should know when working with numeric variables related both with the declaration of variables and assigning variables. You don't need to declare all the variables in the beginning of the block of code. In fact, we can do this. In this case, we can declare the first variable and then assign a value to it. Next, we can declare the second variable, assigning a new value to it in the next line. And the same for our third variable. Another thing we can do is to declare several variables in the same line of code. All of them always share the same data type. As is the case for the second and result variables, they share the same double data type. So we can type var second, comma result as double. And the thing we can't do under any circumstance is declare the same variable again using another data type, or try to declare a new variable using an already used variable name. For example, we declared the second and result variables, and I try to declare a new variable again using the result name, changing the data type to integer, or even to make it more clear, let's say that result is a string variable. If I try to run the app, we can see how the Xojo IDE shows us an error again in the marked line, and the lower area of the code editor is telling us the kind of error, which is clearly because we tried to redefine an identifier, which is the label associated with a variable. In fact, the IDE is even telling the variable that it is already using the same name that you can see in our first line of code. Amongst others, these are some of the most frequent errors when someone starts to learn to code: redefinition of variables, or trying to assign a data type apart from those used during the variable declaration, or even the data truncation as the result of mixing double and integer. Let's say that I declare a result variable as an integer data type, and then I try to assign a string value to it. And Xojo will tell us that there is once again a type mismatch error. We tried to assign a type of data that differs from the one set for the variable declaration, so we can't assign a string to a variable declared to store integer values. Remember, once we declare our variables, we can't assign a different data type to them. And we can't redeclare an existing variable, so it can store a different data type than the one initially set. What we also need to know is that the variable and the data stored by it will only last from its declaration until the execution of the last line in the block of code where it is declared. What is a block of code? That would be all and every line of code that we could write inside the code editor for the open event, although there are exceptions to this that we'll see in future lessons. So in this case, the result variable will exist from the first line where it is declared until the execution of our second line of code where our variable will be destroyed, as would be the case for its stored value. Let's see it in action. For example, we assign the value 10 to it in the second line of code, and then we display its value using the message box function in the third line of code. We can see how this block of code is composed by 3 lines of code, and this variable will last from the first line of code until the third line of code is executed. Once the last line of code is executed, the result variable is destroyed from memory, and its stored value 10 is also deleted. That means that we will not be able to refer to the result variable and thus the value stored in it until the next time the same block of code associated with the open event of window 1 is called again. The next time the open event is called, the result variable will be created again, the 10 value will be assigned to it again, and displayed by the message box function. We can follow this process in a more visual way using another feature from the Xojo IDE. This one is called the code debugger. The debugger lets us see inside our code as a picture, as our app is running line by line, so we can spot in time what values are stored by our variables, amongst other kinds of data associated with the items used in our application. How can we instruct the debugger to pause the app execution in a given line of code? Very easy. If you look at the code editor, you can see in the left margin a series of lines associated with every line of code. If we click on any of these lines, we will be setting a debugger point or breakpoint. So the debugger will pause the code execution once that line of code is reached. In fact, we can set the debugger point on any of these lines of code, or even on all of them, although it will not make much sense to do that. So let's put a single debugger point. So we know that we set the breakpoint in the first line of code associated with the open event of the window 1 window. So when we run our app and it reaches the execution of this line of code, we will be presented with the debugger panel, bringing us access to all of its features and the ability to inspect the value of our variables. At that point, if we run our app, we can see all of this process in action. It reaches the breakpoint we set, displaying the debugger panel in the lower area of the window. We can see how in the left panel of the debugger, we can see inside a block of code. The debugger paused the execution. In effect, we can see how we are inside the open block of code associated with the window 1 window. Precisely where we put our breakpoint. If we come back to the project browser, we can see that in effect, the debugger matches that hierarchy. So the information given by the debugger is very useful to let us know where in the app we are. And if we look to the right side of the debugger panel, we can see the name of the variables declared inside that block of code, amongst other code objects that are also part of the executing app, and we can also inspect from that block of code. We can see how the breakpoint is still on the first line of code, which is the declaration of the variable. So in this case of an integer value, it gets assigned the by default value of 0. In order to step forward in the execution of the app, we can see how the upper toolbar includes a series of icons, every one of these giving us a functionality, resuming the app execution. Stopping the app execution so we can go back to the IDE, executing the next line of code, or executing the next line of code going inside of it, it was a function, or exiting from the current block of code. If we click on the Step Over icon, we can see how the first line of code is executed, and this is where we declare our result variable. Pausing the execution of the app in the next line of code. If we move forward again in the execution of the next line of code where we assign the 10 value to our variable, we can see how our variable result stores the new 10 value. If we move forward executing the third line of code, we can see how the message box function is called, displaying the result variable value as expected. When we click the OK button from the message box, we are brought back to the debugger, where we can see that the end of the block of code has been reached. It will be after this point when our result variable will be destroyed and thus the value stored by this variable. So once we click to run the next line of code, we can see how the debugger exited from the open block of code and the result variable is out of scope, displaying instead another object reference for the items that are now in scope. In fact, you can see how one of these items is the window 1 window, and if we click on it, we will get access to all of its properties, so we can inspect its values at a given point during the app execution. Probably you'll recall from the previous lesson what these properties are. As you can see, the debugger is a very powerful feature, so you can use it amongst other tasks to see if your app is behaving as you'd expect, and also to find any problem during its execution. So once it's detected, you can go back into the code editor to change the code in order to fix it. At this point, we already know how to work with several kinds of data or data types. We know that the string data type, the numeric data types, we also know how to use the common mathematical operators, including what the operator precedence is, and how we can modify that precedence to get the expected result in our mathematical operations, addition, subtraction, multiplication, division module, etc. We also learned some important things we need to be aware of when working with numeric variables, especially when it's about mixing double and integer values. Let's work now on a very basic app. In fact, let's delete all of the existing code, the open event associated with the window 1 window, something you can do by choosing Delete from the contextual menu, or simply pressing the Delete key on the keyboard. So we now have our desktop project as it is created from scratch. Let's start designing our user interface, where the user will type their year of birth, the current year, So the app can calculate their current age after clicking on a button. Let's change the position of every object in the layout. We adjust every control size as we need it. And we change the size of the window. What will our app do? It will get the year of birth and the current year typed by the user in order to calculate their current age, presenting such a calculation through the message box dialog. In fact, let's change the button caption to calculate age. Change the inspector panel and select the Window 1 window in the project browser in order to change some of its properties. For example, its title property to calculate your age. As you probably remember from the previous lesson, the way to associate code to a given event is by selecting the object we are interested in and then the event handler option from the toolbar. Then the event name we are interested in, so it is added to the object hierarchy in the project browser. So the window 1 has controls, one of which is the push button 1 button that will fire the code associated with the action event. It is easier to access every one of these project items in order. Let's go back to the inspector panel so we can change some of its names to other ones that are more descriptive. In this case, it would be born year text field, because it is where the user will type their year of birth, and current year text field, because it is the text field where the user is going to type the current year value. And then we will be back to the code editor associated with the action event for the push button. In fact, let's change its name to calculate age button, because it is always desirable to provide descriptive names both to the UI controls used in the layout and also to our variables. This way, it will be easier to later know what they are intended for once we reference them from our code. Nothing new here, because we already know that in order to access the value stored in a text field, we have to access its value property. But we are going to store that value temporarily into a variable, so we can start declaring our variable using the identification or label year of birth and are able to store an integer data type value. A second variable named current year, also an integer data type. And now we will instruct these variables to store the contents from their respective text fields. Year of birth equals the content born year text field dot value, and current year equals current year text field dot value. Would you be able to answer at this point what you would expect to happen if we try to run our app now? In effect, and as we've seen since the start of this lesson, we have a problem in these two lines of code. As you can see, we declared our variables so they can store only integer values. Well, we already know that the value property from a text field gives us a string data type. And as we previously saw, we can't assign a string to a variable declared as an integer. So we can't add a string to an integer value, even if both contain internally numeric representation. How can we fix this problem? When working with numeric values, we saw that we can use the toString method, so we can convert a number to its representation as a string, and when it's about strings, we can use the opposite method, so we can convert the content of a string to the numeric representation of its value. We can take the data string from the value property and get its representation as an integer value. If we use the dot notation to chain and apply the new method on the value we get after assessing the value property of the text field, then we can choose among several method names that we can apply to it, and one of these is the one we need to use. If previously we could use toString to convert a number to a string, we will use toInteger in order to convert a string to a number of an integer value. We add the same method to our fourth line of code, and now we are going to declare a new variable responsible to store the calculation result. So we type var result. Also as an integer data type, and that equals the result of subtracting the current year to the year of birth. So we store the current age in the result variable. Lastly, we display the result value using messagebox function. So now, what do you need to do at this point in the code? Of course, I'm accessing an integer variable, while the message box expects a string data type. So if we use the toInteger method in order to convert a value from a string to an integer, we need to use the toString method, so we can convert the numeric value stored in the result variable to the string needed by the message box. Let's run our app. We type the year of birth in the field, something like 2009, and 2020 is the current year. We click on the button, and we get the expected value in the message box dialog. We can see several things we can improve in our app. First, the width of these text fields is not the same, but maybe the main problem is visible when we resize our window, because all of our UI controls stick together to the top left corner of the window. So this is not visually appealing at all. So let's try another approach to improve this in our app. The first thing we're going to do is adjust the window size and then reorganize our controls in the layout. We can see how, if we select the control, we can look in the inspector panel both at the width and the height. So we can see that the control width is 125. So we only need to select the second text field and give the same width to the inspector panel, so they both now have the same width. But how can we solve the problem related to the controls position when we adjust the window size? We are going to employ one of the multiple possible approaches that are as simple as redesigning our user interface layout, changing the initial position of the controls, the push button in the lower right margin of the window. And now we're going to use the locking position properties we can find in the inspector panel for every control. When you look under the locking section for the selected control under the inspector panel, you can see a total of 4 locks. Every one of these will set how the control position and size behaves when the containing control is resized. For example, when closed, the upper and left locks will instruct the control to keep its original position over the left and top margins of the containing control. In this case, our window 1 window. While it keeps its size, both width and height values, this is the same for the second text field control. If we want the control to change its size as we change the window size, then we can previously set its width so it matches the one from the containing window. Repeating the same operation for our second text field control, and then also closing the right lock in the inspector panel. This means that the control will change its width as we change the width of our window, keeping the relative position of the control over the top and left margins. We repeat the same operation for the second text field, In the case of the push button, we will do the opposite. Instead of instructing it to keep its position over the top and left margins, we will open these locks, closing the ones for the bottom and right margins. This way, every time the user changes the window size, the push button will keep its position over the bottom and right margins of the window. Let's run our app at this point to test our layout. And now we can see that if we change the window size, the contained controls will adapt their sizes to match the size of the window, and in the case of the push button, it will keep its position locked to the right and bottom margins while keeping its original size. But we still have to deal with another problem. What happens if we resize the window to its minimum size? In this case, we can't see the label text, and also the push button gets out of the window. In order to solve this, we can use another of the available parameters or window properties from the inspector panel. Once we select our window, we can access the minimum width and minimum height properties under the size section. So if we keep the original window size as the minimum resizing size, the user can't change it even more. Then we only need to set these values as the minimum allowed width and minimum allowed height, entering for that the current width and height values as the minimum width and minimum height ones. So let's run our app again to test these changes. And we can verify that now the behavior of the window resizing is the one we expect, allowing the user to change its size at the same time we keep the minimum size set under the inspector panel for the window. Our app still has an additional problem related to its logic. We can type our birth year and the current year, but nothing stops us from typing any numeric value longer than the one expected. So if we use these values for our calculation, the result will be wrong. In fact, nothing stops the user from typing any alphanumeric value containing just characters. So once again, the logic of our app would be throwing a wrong result. How can we fix this? Let's see. When we select a text field control in the layout editor, and we look at the properties available in the inspector panel, we can see that one of the sections is labeled behavior. And here we can find the validation mask entry. We can set the allowed input from the user here for the selected text field. For example, we can type the number sign character, both to define the kind of data the user can type and the number of characters allowed for the input. In our case, a year is composed by a total of 4 digits, so we type 4 sharp characters for the validation mask. We repeat the same operation for our second text field, 4 characters. So we are instructing our text fields that the user can only type digits and that 4 is the maximum allowed of digits as the text field entry. In addition, we can also set the text alignment for the text fields, setting it with the right option because this one seems to be most appropriate when it is about displaying numbers. Let's test these changes. Now we can see how the text cursor is set to right of the text field instead of aligned to the left. And if we try now to type some character apart from digits, we can see how these are not allowed as part of the input for the text field control. It will only accept digits as the input for the field, and in fact won't accept more than 4 digits for the entry. So we can see how using the validation mask for the text field, we can set its input behavior easily, limiting the kind and amount of characters from the user input. So if we now type 1999 in the first field and the current year in our second field, the output from the calculation is correct. At the same time, we achieved a more appealing user interface. In the next lesson, we'll see more instructions and keywords from the language, so we'll be able to start working on a bit more capable application examples than the ones we've already created. We already saw how to work with variables, what a data type is, and it's time to move forward to more advanced instructions and concepts from the Xojo programming language.